TSQL Language Primer. All right, so we need a way to work with our data stored in our database. We need a way to pull data out. We need a way to put data in. We need a way to modify the data. And we also need a way to remove the data. We also need a way to work with our data objects, so our tables, our stored procedures, our views. So for that, we need a way to create objects. We need a way to drop objects, which is, of course, deleting them. And we need a way to alter objects, which is manipulate them. Now, what I just mentioned is all of the ways to work with, programmatically work with all of these database objects. What I'm talking about here is SQL, the structured query language. And ignore the T dash here for a second. What SQL is, it's what's known as an ANSI standard. ANSI stands for the American National Standards Institute, and it's just a community out there that said, you know what, way back in the 80s, they had all these products budding up, such as Oracle and Sybase, and IBM had their own DB2 platform. But basically, we had all these database platforms that were different from the outside and had different features and such, but underneath the hood, they were still RDBMSs. RDBMS stands for Relational Database Management Systems. So sure, they all have their own features and such, but you know what? Underneath the hood, they're the same structure. They're still a relational database management system. They have tables that hold data that can be related to other tables, so on and so forth. So the ANSI community said, you know what? If we're going to have all these different products out there that still have the same hood, the same structure underneath the hood, why not create a standard way of accessing that data across the board? So if I'm working with 3 different database platforms, I can still use this one standard way to access all of that data. So that's what they did, and that's what SQL by itself is the structured query language, and it is an ANSI standard. The T dash in front of it, however, basically means that it's an extension to the language. So Microsoft went out and said, you know what, we have all these bells and whistles that we can throw in to SQL Server because it's our product. We need a way for our users to programmatically work with these bells and whistles, and that's why they added the T dash in front of it. Just basically means it's their own proprietary extension to the SQL language. So yes, SQL Server supports all the standard ways of accessing relational database management system underneath it, but it also has its own stuff on top of it that we can use to access SQL Server specific stuff. Take Oracle, for instance. Oracle has their own extension as well called SQL Plus. So that's just their version of T-SQL over there in Oracle, their own way of accessing their other features and bells and whistles. So that's pretty much what T-SQL is all about. Now, that's what we're going to be studying in this video. We're going to take a big, deep look at Transact SQL and how it works. And so we'll begin here with an introduction to Transact SQL. I'll get you familiar with all the different components that make up the Transact SQL language. We'll define what DML is. I'll get you into all the different statements and how they look and how they work on paper. And same with DDL and also a few things inside of working with Transact SQL here. And after we're done kind of getting a bird's eye view on how all this stuff works, we'll jump right into SQL Server Management Studio and get familiar with how to do things. So we'll get very familiar with the data manipulation language here. In other words, I'll get you really good with the select statement, with the insert statement, the delete statement, the update statement, and also we'll work with the join operator and get familiar with all the different ways we can join related data together across multiple tables. We'll then move into working with Transact SQL. I'll get you familiar with how to use variables, how to use functions, how to use control of flow language statements. I'll also get you familiar here on how to understand syntax, because I believe if you can understand syntax, then you can learn anything. And that's what it's all about. Think about it. Learning any form of actually communication language, such as English or Japanese or Russian, whatever. If you can understand the syntax of the language, it's very easy to pick up the language. And that holds true for programming languages as well. So we'll get a good understanding of how to work with syntax. And it'll also get you familiar here with working with coding conventions. Because if we all use coding conventions, it's much easier to read each other's code, let alone reading our own code. Even if we have our own convention, we'll be able to just much more efficiently work with our code and other people's code as well. So at the end here then, we'll take a big look at an introduction. Really just, I want to get you familiar with the data definition language. And these are going to be the create, drop, and alter statements for creating database objects, whether you're creating a table, a database, a stored procedure, a view, you name it, whatever kind of object we're creating. DDL is how we're going to create it in code. And I want to get you familiar with, because all the future videos, we're going to be dealing with just that, creating databases, creating tables, views, stored procedures, data types, tables, so on and so forth. So it's good to get a good introduction here to how the data definition language looks and how it works, because it'll make it much easier to create all those objects in our future videos. So let's get right to it here. We're going to start off with an introduction to Transact SQL. What I'm going to do is I'm going to get you familiar with all the different components that make up the Transact SQL language. We have what's called DML, the data manipulation language. We have what's called DDL, the data definition language. And then we just have some common Transact SQL components that you're going to be working with every day when you work with both of these, DML or DDL. So let's start over here with DML, the data manipulation language. Again, this is just a fancy term that describes a subset of statements in the Transact SQL language. Now, before we go any deeper into the DML statements here, I just want to get you familiar with what a table is in case you're not familiar with it already. And a table is the lowest level of data storage inside a SQL Server from an interface perspective. What I mean by that is from SQL Server Management Studio and also from a statement level when we use these statements to get data. How the data is actually stored in the files underneath in SQL Server is a whole different matter, and we will discuss that matter in another video. But again, to keep this simple, we just have a table. And a table is just kind of a tabular format here where we have rows and we have columns. The columns define what type of data can fit in this specific column. So in our ID column here, we would define this as an integer, which means only numeric values could fit inside of this row, numeric values of a specific range. Same with this text column here. We would consider this a character column, and we would define it as a character column, as being the first name. And of course, we can define the amount of characters that can fit in this column on top of that. So columns just define what type of data can fit in them here. Rows are the actual data themselves that contain all of the columns that make what's called a record. So in our example here, we have two tables. We have our person table and our employee table. Person stores person information, employee stores employee information, and we're going to use DML to manipulate and work with the data inside of these tables or any tables. We use the select statement to pull data out of tables and to read data. And there's lots of cool things we can do with the select statement. I'm going to cover most of them, all the basics, and then some, even some new features in the select statement in SQL 2005 that we'll take a look at. But basically, we can use select, again, to pull specific rows out of a table, to pull specific columns out of a table, all based on criteria that we define. We can sort data in a table, group by data in a table, lots of things we can do. As I said, select statement is probably the most common DML statement out there, and we'll take a big look at it and how to use it. We also have the insert statement, very simple statement here used to put data into a table. We have the update statement that we use to modify and edit data inside of a table. And we have the delete statement to remove data inside of a table. Also, we can work with what's called join operations. And joins are what we're going to use to relate tables together, tables that have related data in them. Now, why we use joins, that's a whole nother topic, but let me say that we're not going to store all of our data in one big table because that would be a mess. It would be bad on performance. We would have redundant data. Lots of reasons not to put all your data in one table, kind of like putting all your eggs in one basket. But think about it for a second. Let's say that we have a person table, we have an employee table, and we also, let's say we have a customer table out there. Well, if we were to put all that data in one table, we could have employees that are also customers. So what that would mean is we would have two records of the same person. So that's redundant and also bad on performance and a whole host of other issues that could come from that. But we use joins to combine these tables together and pull data out that would look like it was all in one table, but it really wasn't. So we'll get really heavy into joins, but just to give you a simple example here, let's say we wanted to join these two tables together, our person and our employee table. Well, we would write a select statement that would join them based on our common column here, which is our ID number. So we could pull the first name and the last name out and maybe the hired date out, and it would look like one table to the user, but underneath the hood, it's two tables that we related together to pull the like data out. So we'll get really heavy into joins and how they work as well. Now we also have DDL statements, the data definition language. As I mentioned before, we're going to use these statements to work with database objects directly. So if we wanted to create this table, we would use the create object. If we wanted to add a column to this table, we could use the alter statement. And if we wanted to drop the table or delete the table entirely, we use the drop statement. And these DDL statements work with pretty much any object you can create in the interface inside of SQL Server Management Studio there. We can use DDL statements, Transact SQL code, to do the same thing in code. So each whether you're creating a database or a table or a view, the syntax is a little different for each one. So I'll show you how that works. But we use DDL just to manipulate our actual objects. We then have some common Transact SQL language components that we're going to get into. Variables, very common to use variables. Variables really are used for, in scripts, they're used to store values, We set up all our variables at the top, and then if we use them more than one time within our script, we don't have to change it every single place in our script. We just use the variable to reference the value. So variables are also used as parameters into stored procedures. So users supply the values through these parameters, which are stored in variables. So it basically allows us to create dynamic queries where users decide our conditions and our parameters that the queries will run off of. So we'll take a look at variables. We'll also take a look at functions, which are just built-in operations. We'll take a big look at functions and how they look. Predefined operations inside of transact SQL. Tons of functions we can work with. We'll also take a big look at the control of flow statements. Specifically here, we'll look at the if statement, the if-else statement, and we'll also take a look at the case statement. So we can do things such as decision making, and we can also do conditional formatting of our data. We'll take a big look at that. And as I mentioned here, we're going to get familiar with syntax, because if we understand syntax, we can really get a hold of the language and just run with it. Once you understand how the syntax works and how to read the language, very simple to pick it up. And also, as I mentioned here, we'll take a big look at coding conventions and get familiar with how to structure our code appropriately so it's easy for us to read and others to read if they were to use our code. So these are all the components in Transact SQL that we're going to be working with in this primer video. Let's get to it here and start off with DML. We're going to begin getting familiar with the select statement and how to manipulate data. So to do this, let's head on into SQL Server Management Studio by going down to Start, dragging up to Programs over to SQL Server 2005, and right down to SQL Server Management Studio here. We'll fire it up. I'm going to connect to our production database and our Object Explorer here. And then also, I created a script. And I'm going to open up that script by going to File, Open, and then File again. And inside of our T-SQL Primer folder I made here, we're going to start off with DML. I'll double click on that, and we'll connect our script right up to our production database as well. And then I'll change this to AdventureWorks. So we're going to be working in the AdventureWorks database here. So if we drop down our databases node, here's our AdventureWorks database. If we drop down our database, go into our table folder here. Here are all the tables we're going to be working with. I'm going to go ahead and hide our registered servers so we get a better view of just everything inside of our AdventureWorks database, because we're going to be working with quite a few of these tables in here. I'm going to jump around and just overall get you familiar with this database, because it's a great test database to do things such as learn a programming language on, learn Transact SQL on. So we're going to start off with the select statement here, and we're going to take a big look at the select statement. The first thing I'm going to do is show you what we're going to do with the select statement. We're going to start off working with the human resources.employee table. So if we go into our Object Explorer here and we drop down the employee table, you can see if we drop down our columns folder, here are all the columns in this table. Now one thing you can do is you can right click on the employee table and choose open table, and this will actually open the table up and give us a look at the entire table, all of the data inside of it, every column, everything. So here it is. Here's all that data inside of this table. You can scroll around, look at it, do whatever you want to do with it, but here's the data inside of here. And again, this is regarding an employee. So if we wanted to grab just what we did, all rows, all columns, we do a select followed by the splat, or otherwise known as a star. So we're doing a select star from table. So it goes like this: select followed by your column list. A star means everything. Give me every column. The from keyword here followed by the table that you're grabbing all the data from. Now, in this cool thing about our query editor here is if whatever you highlight, that's only the code that's going to get executed when you hit the execute button. So you'll see me highlight this and then hit execute, and boom, there it is. Now the interesting thing about this is here's all of our data, and if we go ahead and we right click on this employee table and choose open table, that's exactly what this is doing. It's doing a select star from whatever table you're right clicking and choosing open from, because this is the same exact data. Same exact data. We got 290 rows here. If you close this out, we look down here, check it out. Same exact data, 290 rows in here. And even though you can't see it, let me go ahead and hide this. There you go. See this down here? All the way on the right here is your row count. 290 rows. Took 0 seconds to execute. Connected to the AdventureWorks database, and it just shows us that it was executed successfully. So I'm going to pin back down our Object Explorer here, and that's all that did. Now, instead of going to this, I like to hide this pane so we have some room to work with here. Instead of going to Window, Hide Results pane every time, like I've been doing, I'm just going to hit Control-R. So if you see this disappear, I hit Control-R, and then I can hit Control-R to show it again. So that's all I'm doing there. So that's as simple as it gets with the select statement. Give me everything from human resources.employee. So it returns all columns and all rows from a table. Let's take this a step further. What if we wanted to only grab specific columns from a table? Well, to do this here, I'm going to head on down to our person.contacts table. You can see here the columns inside of our person.contact table. We're going to say for this one, we only want to see the title, the first name, the last name, and the email address from our person.contact table. So that's all we do. We just separate it out, column name, comma, column name, comma, column name, comma, except the last one, do not put a comma. Let's highlight it, hit execute, boom. There it is, our person.contact table, all the person contacts inside of here, and their email addresses, and their title. You can see some of them have a null title here. That null means nothing. There's no data in there. That's pretty much all there is to that one. So pretty easy to break them out here by column. Just put commas after your column names. Next thing we have here is the where clause. Let's say we wanted to filter out specific rows. For instance, if I open up this contact table here by right-clicking on it and choosing Open Table, you're going to see there are probably 19,000 in some, I do believe. Yep, 19,972 rows. That's a lot of contacts. Let's say I only wanted to extract my contacts that have a last name of Adams. Well, we just simply put a where clause on it, where column equals value. So that's all we're doing here is saying give me the first name and the last name from person.contact where last name equals Adams. And whenever you use a string value here, you have to separate it by single quotes. So yeah, and close it in single quotes, excuse me. So we just highlight this code here, hit execute, boom, there we go. There are all of our individuals in our contact table with the last name of Adams. Pretty simple there. Now, taking this a step further, let's say I wanted to grab anyone that started with an A. Well, this is where you can use these operators. You can see these are just operators here. So we could do something like this. We could use the like operator. We can do an A, and then the percent sign here is a wildcard. It means give me A and anything after. It can be anything after, but it has to be after it, right? So this would say anything that begins with A. So if we highlight this and hit execute, here's everyone that has a last name that begins with A. Now, if we wanted to do something where we wanted anybody's name with an A in it, then we could do that. So this would give us anybody that has a last name with the letter A in it at all. If we want to do something where the last name ended in A, then we could do this. And there you go. Here's one where all the last names end in A. So that's how wildcards work and the like operator. You could also do something like this. Let's say we wanted to do where the last name is less than Adams. So this will actually do a character comparison. If we hit execute, all these last names are alphabetically before Adams. You can see there's not too many of them, but that's how that works. So just use comparison operators here. Equal is a direct equals, last name equals that. You can do greater than, less than. You can do does not equals, and then you can do like for your character matches and wildcards as we did below. Now, on a side note, I'm actually going to show you in the next segment when we talk about functions about how SQL Server knows how to do these character comparisons. In other words, how it knows that Adams is less than Anderson's. So when you're comparing characters, comparing numbers simple. We all know math pretty well. It's ingrained into our brains. How does it do characters? And I'll show you that in an upcoming segment. Just good, useful information that may come in handy someday. Before that, though, back to the select statement. How do we sort data? Well, sorting is very simple. It's controlled by the order by statement here. We can use order by after our where clause. If you don't have a where clause, it comes after the from clause. Pretty much it always comes at the end of everything, though, in general. But it's pretty simple. We just use order by and then the column name. And you can specify how you want to sort it, either ascending or descending here. The default is ascending, and of course, since it's the default, you don't actually have to specify it. But if you do for clarity purposes, you can just put an ASC there. Also, we have DESC for descending. So ascending is A to Z for characters. For numerics, it's 0 to 9. And then for dates, it's lowest date to highest date. For descending, it's just the reverse of that. But let's say, for instance, that we wanted to just get a list of the same exact results above here, only this time everything that has a last name of A, and we want to sort it by that. Ascending first here, so we'll just highlight our code. We'll hit execute. Here we go. See, sorted by last name from the A's downward. So we got a boss all the way down to Ayers. So pretty simple to do some sorting. Let's say we wanted to do a dual sort. We want to sort first by last name descending, then we want it to sort by first name ascending. No problem, just specify your sorts with a comma, and then it'll do a dual sort. So first it'll take these results, it'll order them by last name descending. Once that's done, it'll take it and order it by first name ascending on top of that descending. So if we highlight this and hit execute, you can see, sure, we're still going to be sorted here, Ayers to Abbas this time from, again, descending on last name. But if we get a last name with multiple ones here, you can see now our first name from the ashes, see there's a lot of ashes in here, there we go, is going to be sorted from A to Z. So now last name, Z to A, first name, A to Z. Now let's take this just one more step further here and talk about grouping. Grouping is good for when we want to do aggregations on our data. In other words, we want to group by a specific column, which will roll all that data up. And then based on other columns, we can do things such as counts, which will just give us a raw count of how many fields by that specific column. We can do averages on the data. We can do mins and maxes, which are the lowest value and the highest value. We can do sums, which are totals. So lots of aggregation, lots of aggregates out there, aggregate functions and such that are out there that you can use. In our instance here, let's say we wanted to go into the employees table. So if you scroll on up here to the employees table, you can see we have a title column. Let's say we wanted to get an account of employees by title. So we want to see how many employees there are per title. No problem here. We can just use a standard select statement. We say we want to see the title here, and that's what we're grouping by. You actually optionally can show the column that you're grouping by. But all the other columns, you're going to have to do an aggregate function to roll up that data based on those results. And you can do multiple grouping levels here. You can add a column and do multiple groupings as well. But to keep this simple here, if we just highlight this, hit execute, now it's going to go into the employees table here, which if we open this, you can see there's 290 records, right? Each employee, here's that title column listed out. Well, our grouping just basically took here, and I'm just going to show you here, we got 67 rows back, but that just went ahead, went into our title table here, or excuse me, our employee table, grouped it by the title column, rolled all that data up, and then we just did a straight count based on that data. So it just counted how many employees have each title. So if we scroll down in here, you can see we have 9 buyers. We have a lot of different technicians, a lot of technicians in the AdventureWorks company. And even if you look in the D's here, look at that. We have 2 database administrators. Pretty cool. So that's how we can do groupings. Once again, and taking this another step further, let's say that we wanted to get unique values in our record set. Well, I'm going to take this distinct out of here first. If we just ran it like this, select title from human resources.employee and hit execute, this is going to give us quite a few records back. As you can see, I'm going to hide our Object Explorer there. 290 rows, right? We're going to get a record for each employee in the database. So you'll see a lot of duplicate titles in here. Now, let's say we wanted to get what's called a distinct list of that, or just basically a list without the duplicates, because we want to see every single title in our company. Well, to do that, we can just come back in here and type in distinct. And that'll give us a unique count from our human resources.employees table. So if we hit execute here, I'm going to hide this once again. Now we should have 67 rows, just like our grouping did, because our grouping, since we group by title, will just give us a distinct list. The difference here is, of course, it rolled up all that data so we can do aggregates on it. This one, however, just simply went out and gave us a distinct list of all of those titles, a unique list, in other words, of all those titles in the employees table. And one more interesting little note about distinct here is you'll notice in our group by here, our count function. The count function actually takes a parameter here that can either be a splat, as we did here, which means count everything no matter what, but it also, you can pass in distinct. So if you put distinct in here, it'll count only the distinct value, so it'll never count the same value twice, whereas splat, again, counts everything. So it may come in handy someday. Also here, when we talk about the union operator, and the union operator allows us to combine results from multiple sources into the same data set, the same result. So for instance here, we want to do a select everything from production.product category. I'm just going to run this quickly just to show you. We have 4 products in here, and you can see they're all listed out. This is everything from the product category table. Now, the union operator, again, allows us to combine results from another query. The only hitch here is that this query that you're unioning in must return the same exact data. And what I mean by that is, sure, the names of the columns can be different, but their data types have to be same. So in other words, we have to have 5 columns here because we have 5 columns with the same exact data in the same exact position. So let's say we wanted to, for instance, add our own record onto here called test category. Well, we can just do a select, and then I'm just adding in static data here. For instance, 5 is going to go in here. Test category is going to go in here. A new ID, this function just generates a brand new what's called a GUID or a GUID globally unique identifier. And then the last column here, we're just going to put in a dummy date. So if we highlight all of this and hit execute, there you go. You can't even tell that this test category came from another source or another query. It's all compiled and returned in the same result set. Now, taking that one step further, union by itself trims out duplicates. So, for instance, if we do something like this, if we say a union all, and then well, let's go ahead and add another one here. And I'm just going to highlight this code. So this is since I didn't highlight this order by over here, and I'll explain why I did that in a second. But we're not including that. So it's just like select star from product category, add our own row, and then do the same exact query. So this, if we were to take out the all, should give us the same exact results we have here, just 1 through 5. And if we hit that, boom, look at that, no difference at all, right? You couldn't even tell we had another query in here. If we do an all, however, I'm going to highlight just that same exact data here and hit execute. Check it out. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, because again, there's only 4 records in there. We added the 5th one up here in the middle, and it came back just like that with duplicates because of the all here. Now, the reason I added this order by on the end here, because you see, you couldn't do an order by up here before these unions. It would actually blow up and you get a syntax error. If you want to sort when you're doing unions, it has to be on the very last query that you're unioning in. So that's why I added an order by descending here. And if we go ahead and hit execute, you can see it's going to take all of those results, combine them together. And since we did an all here, you can see it's added the duplicates in here as well. But now they're all sorted descending to ascending. So just another interesting little tidbit. I'd like to throw these in because they've come in handy for me in the past. Hopefully they will for you someday as well. Now, the last thing we're going to look at here with the select statement is something brand new to SQL Server 2005. We have 2 new operations that we can utilize called accept and intersect. And these are really cool, really big time savers. Let me just go ahead and hide Object Explorer here. I wish these were in previous versions of SQL Server because they would have saved me personally a lot of time. I used to try to do these things using joins, and it was just always some crazy logic to get it to work. But nonetheless, it is now all done for us. And what accept and intersect do are pretty cool. Accept, and both of these work very similar to how union works, only instead of combining result sets, we're comparing result sets. So using accept will give us the difference between 2 result sets. Intersect will give us the similarities between 2 result sets. So for instance here, what we're doing is, again, we're working with this product category as we were with our union statement above here. Only we're going to add a filter in here. We're going to say, give us all the records out of the product category table where the product category ID is in this list of values. And the in comparison operator is really cool. It just allows you to basically grab records based on a comma separated list of values, which is what we're doing here. So for instance, this actual query, if we hit execute, highlight it, hit execute, will give us those 4 records, right? Because we told it to. If we scroll down here and run this select statement, it'll give us those 3 records. So if we put an intersect between the 2 and run them both, we should get the same results, 1, 2, and 3, because 1, 2, and 3, since an intersect gives us the similarities here, are the only records that are in both result sets. 4 is not. If we change this, however, to an accept, and then highlight them, we should get the opposite. We should only get number 4 now because the 4th record is the only one that is not in both of those result sets. So very, very cool, simple to do operator here. And as I said, this would save me probably many, many, many man hours in the past because you used to have to accomplish this through some crazy join logic. But now, done for us. Very, very cool. Very happy about these new operations. Now, the next thing we're going to do here is talk about joins and working with joins. In other words, we're going to take data from multiple tables, write a query that extracts that data and combines it together, but doesn't really combine the data, actually combines the data through a relation, and then returns the results. And to give you a little background on how this is going to work here, take a look at the AdventureWorks database. There's a great example of why we would be doing this, for instance. And it comes in the form of the employee table, the contact table, and the individual table. All right, here's how it works. We have an employee table up here, and our employee table doesn't hold any person information, any contact information, right? An employee still is a person, but we don't need to duplicate that information because we may have an employee that is also a customer, in which case we'd have redundant data, right? We'd have to manage that employee and that customer separately. If we have a name change, guess what? We'd have to change that name in the employee table and in our customer table. Well, uh, Microsoft built their sample database here, the AdventureWorks database, with normalization in mind. Normalization, just a standard database concept out there when talking about reducing redundant information, increasing performance by building a database, right, using something such as this, by taking data, splitting it out into multiple tables, and then relating it together when we need to extract that data out. So the employee table, information about an employee, but not necessarily a person, right? If we scroll down into the customer table here, the customer table has a customer ID, which is linked back to an individual. As you can see here, here's our customer ID. So the individual table and the customer table are the ones that hold information about a customer. And both the employee and this individual table then link back into our contacts table, which stores information about a person, right? Contact information about a person. So if we wanted to get uh, person information from our employee, we wanted to find out all the first names, last names, and email addresses of our employees, we could do that by linking our employee table to our contact table to do so, because we have a common ID in here. We have a contact ID table here in our contact table. And if we scroll up here into our employee table, we have a contact ID in here. So we know that we can link this data together, and we know that that employees have contact information. So we can do that through the contact ID column. And if you scroll down here to the sales, that individual, you can see, also has a contact ID. And these are called foreign keys because foreign keys have primary keys in other tables. As you can see here, our primary key for our contact table is a contact ID, and the foreign keys for our employee table is then the contact ID, and same with our individual table below. So the first thing we're going to look at is an inner join, and rather than get you familiar with the syntax and how all of this works in code, I'm going to show you how it works on paper first. And it's easy to understand how it works on paper before jumping right into the code when it comes to join. We can do that with the select statement because it was simple to get the hang of. Joins are a little more complicated just at first glance, but believe me, they're actually a breeze once you get into them and you use them a couple of times. This is how it works. An inner join is what we're going to first look at. And let's say we have our employee table over here on the left and our contact table over here on the right. Now, how this works is whatever table you decide that you're going to join from. In other words, we're going to take our person table over here and we're going to join it to our employee table. Basically, we could think of our employee table then as the left-hand table and our person .contact table here as our right-hand table. And I'll show you how you can decipher that in code. Basically, what happens is if we were to write a join here, we would say, okay, this is our column, our common column. So this is the column we would be joining on, our ID column. And we would write a query to extract whatever columns out. The inner join would say, okay, I'm going to go get data. Well, what it would do is it would say, yep, I can get this. I'll return this row because this has a matching record between the two tables. It would grab number 2, it would grab number 3, it would grab number 4, but it gets to number 5, it'd say, you know what? There isn't a matching number 5 in this table over here, so I can't return this record. So what we would get is we would get a results that would combine data from both of these tables. Again, depending on what columns we chose in our select statement. Maybe we chose first name, last name, and the hire date. We want to see the hire dates of all of our employees that have contact information. Well, there you go. We'd return first name, last name, hire date from these two tables, and we would get those 4 rows back. So an inner join just returns the data that has a matching record between both your left and your right hand table. And if we go back into our query here, and if you look here, we have all of our our standard select statement with all of our columns here listed out. I'll explain what these PCHEs, these are called aliases, and I'll explain these in a second. Ignore those are there for now. But you can see when we get to our from clause, same thing. We're just selecting from an employee table. The difference here is we then use an inner join condition. And we say we want to join our contact table to our employee table, right? How you can decipher that this is the left-hand table and the right-hand table? Well, anything before the join is your left-hand table. Anything after the join is your right-hand table. So you can see here, we're joining our contact table to our employee table, and we're saying join them on the contact ID column. And it always goes on left-hand table column equals right-hand table column. And then, of course, you can decipher that anything before the equals is your left-hand table, anything after the equals is your right-hand table. So that's it. That will join the tables together. Now, in our select list, we can put columns from either table and return them in the output, right? Simple as that. Now, these aliases. Because we have something like this going on where we have a column that has the same name in both of these tables, we have to alias them. And you could do this by just specifying the full-blown table name before the column name. But that kind of gets redundant. It's a lot of typing, especially now in SQL 2005 that we have schemas to worry about. Yeah, these will get really long really quick. So it's easy to just alias them. After you declare the table the first time, you just use whatever alias you want to use. You can type in anything you want in here. I like to use the naming conventions, you know, the first letter, the schema first letter of the table. You can see, so PC here for person.contact and HE here for human resources.employee. Now, I can just prefix all of our column names with those, you know, alias, dot, column, and boom, we're good to go. If you did run this without an alias and you had title here and title here, you'd get an error that would tell you ambiguous column names. We have the same column with the same name in both tables. Please do something about it, such as alias it or fully qualify it with the name. So this is called table aliasing. It's also really good to do when you have a lot of joins going on for readability purposes. Someone else comes and looks at your code that isn't really too familiar with the system. Guess what? They will be, because they'll know what tables these belong to. So aliasing, it's good for multiple things. It's good for when, of course, you have same column names in multiple tables in a query. It's also good for readability purposes and other things as well. Now, another thing I want to show you here is we're also aliasing our columns. So you can alias your tables here, and you can also alias columns by just adding an as and then the name of it. You can also do column name equals. So you could do this as well. Equals he.title. Just another way of writing the same exact thing. Same exact thing as doing the as. I like using as just because, you know, you get the blue thing here, so I know that it's an alias. I get the blue syntax coloring. But whatever suits your needs, floats your boat, use whatever you like. Now let's get back to our query here. What we're doing is we're going to take all of our salaried employees out of our employee table, and we're going to get first name, last name, the title, and then we're just going to get our vacation hours and sick leave hours. So maybe we can get a compiled list of all the time. You know, it's coming up on summertime. People are going to want to use their vacation hours and such. We might as well get a handle on that. So we're going to do that. And of course, we only want to do that for salaried employees. So we're going to add a filter here saying we're salaried, our salaried flag equals 1 in our human resources table. And you'll notice in the order by clause, I didn't alias anything. You don't have to, just to show you that you don't have to here. And that's because we didn't have to, because there's no last name and first name in the employee table. So SQL Server will automatically be able to resolve those names in that table. So let's go ahead and highlight this query and hit execute. There we go. Look at that, no problems here. We got, if I scroll down here just to show you the query, you can see we have our first three columns are from our person.contact table, and our next three columns are from our human resources table. And you can see, there they are, and you can see there's our column alias comes across here as personal title for our person table, and our position title comes back as position title, just to show you that both of these aliasing techniques work. And that's it. So that's how an inner join works. Pretty painless, just a matching records between both your left and your right hand tables. So inner join, definitely the most common type of join out there, but there are other joins that may come in handy here. The next we're going to take a look at is outer join. So if we flip back to our slide over here, we have a couple of different types of outer joins. We have left and right outer joins, which work the same way. It just really depends on what table you're doing the outer join on. And then we have full outer joins here too, which we'll cover in a second. A left outer join, for instance, again, this just kind of depends on where the table is. But let's say we have our left-hand table here and we have our right-hand table here. Once again, employee table over here, contact table over here, same as above. If we were to do a left outer join from our left-hand table to our right-hand table, what would happen is we would get something like this. We would get all the rows that are inner join would return. It would do that first. And then if we do a left outer join, it would basically say give us all the rows in our left-hand table, no matter if there's a match in our right-hand table or not, and return them. So it would return this record. But SQL Server would have to put some type of data in here, right? So there has to be something. There can't be nothing. So what it does is it makes a dummy record for these columns and nulls them out. So it would return those rows. They would just have nulls in them. So empty values in place. So those are outer joins, and they do have their place in the world. Believe me, you will be using them if you're going to be doing any development in SQL Server. You will come across a need for a left or right outer join. Right outer join, just the opposite. It would say give us all the rows from our right-hand table, and then only the matching rows in our left-hand table. So if we run back into our demo here and take a look at how this works, And what we're going to do to show this join here is we're going to take our product table and we're going to outer join it, a left outer join it to our product review table. So let me just show you what this would look like with an inner join here. I'll just go ahead and delete that. And by the way, inner is actually completely optional here. You can just do a join. A join by itself is an inner join by default. So if we just highlight this query here and hit execute, it's going to give us only the products with reviews. Okay. Now, let's say that we didn't want that. We wanted to list out all of our products, whether they had a review or not. And of course, even the ones that do have a review as well. So if we do a left outer join here to our product review table, highlight everything, hit F5 here, or hit execute. I like to hit F5 quicker. You can see we're going to get all of our products listed out, and then whether it has a review or not. So you can see there's one in here, a couple with reviews. There's only 4 in the entire product review table. So out of our 505 products, 4 of them have reviews, but at least doing a left outer join, we have each product listed once, and then whether it had a review or not over on the right. And you can see where it doesn't have a match, it just fills them up with null values. So that's how a left outer join works. Again, right outer join works the exact opposite, just gives you all the rows from the right-hand table and only matching only matching ones in the left-hand table. So that's how left and right outer joins work. We also have full outer joins. And just to show you how a full outer join works here, let's flip back to our slide. And a full outer join is really the combination of a left and right outer join. For instance here, let's add a column here into this table, or a row I should say. And we'll say this is number 7, and there's a first and a last name in there. Again, an outer join, just a combination. It first does a left-hand join, and it'll, of course, return all of our standard rows here. All of these for our full outer join. And then it'll also say, okay, I see part of the 5 here. Doesn't have a match. Okay, great. We'll return null values inside of here. So return some null values for the 5 in this table. And then once it's done doing matching our left to our right, it would do the opposite and say, okay, return all of those, which it already did. Say, all right, number 7, you're not in this table. We'll return the data out of this table, and then we'll nullify the columns over in that table. So just do a left join, and then it would do a right join. And any data that's in the left table that isn't in the right table, it would null out for the data in the right table, and then just vice versa for the left table. So how this works now, if we flip back to our demo here, you can actually do some pretty tricky and cool things with the outer join. For instance, what we're going to do here is we're going to say we want to know what products do not have sales on them. So we can do this by outer joining the product table to the sales order detail table, and then putting a filter on and saying where the product ID is null in the product table, or where the product ID is null in the sales orders detail table. And what this will give us when we hit execute here is, again, it'll give us all the products, regardless if there's a match or not, that do not have sales in our sales order ID table. So you could do some tricky things, outer joins. They do come up every now and then, but it's just a left and a right join combined into one. One other thing to mention here is the word outer keyword here is actually optional. Just like with inner, you can just use a join. With outer, you can just do a full join or a left join or a right join. Optional keywords. Also, one final note about joins here, we do have something called a cross join. And a cross join, very, very rare that you'll ever come across this. But basically a cross join you don't match on any column or anything. It's just simply table name cross join table name. And what that'll do is it's known as a Cartesian product, which is all the rows in the left-hand table multiplied and cross-joined with every single row in the right-hand table. So what you get is basically all the rows in the left-hand table. So we'd have 5 here multiplied with all the rows on the right-hand table. We have 4, so we'd get 20 rows back, 1 for each row in each table, cross-joined with each other. So again, very rare circumstantial need for this type of a join, but it is there in case the need does come up. All right, so now that we're familiar with reading data out of tables using select, and we're familiar with combining data between 2 tables using join operations, how about putting data into tables? Well, we're going to accomplish that using the insert statement, and it's a very simple statement to get the hang of. It's just simply insert. Optionally, you can use the into keyword here, followed by the table that we're going to put this data into. We then have an optional column list here, and I'll explain a little bit about this shortly. But basically, if you want to specify what columns you're going to put data into, you need to put them here in a comma delimited list inside of parentheses, as we do here. We say we want to put data into the name column, the start time column, the end time column, and the modified date column. Once you define what columns you want to put them into, then we specify our values keyword, followed by our list of data that's going to go in. And this is sequential according to how we defined our columns above here. So name is going to be nocturnal. Start time is going to be 12 o'clock p.m. End time is going to be 8 o'clock a.m. And our modified date is going to be whatever the results of the getDate function return. And that's it. And this is a very simple statement to get the hang of. Just to show you what we're going to do here, let's go down into our shift table. We're going to be working with our human resources.shift table here. So let me open this table up here by right-clicking on it, choosing open. And here we go. We have all of our rows in here. You can see you have a shift ID, which is just an auto number column that'll get incremented every time we put a row into here. Unique identifier on the table. We also have our name column, the name of the shift. And then we have our start time, end time, and modified date. So I'm going to leave this table open here and head back to our DML statement here, our insert statement, highlight it, and hit execute, and it'll tell us one row has been affected. So now if we head back over to our shift table and hit refresh, boom, look at that. We now have a nocturnal shift column. So taking this a step further, let's say that we wanted to create an insert statement and we didn't want to specify the columns. Well, no problem, we can do that. You can see this statement differs from this one in the fact that we just do not specify columns. And you can do this when you have every column covered for data. In other words, if you take a look at our shift table, for instance, we have 5 columns, right? Shift ID, name, start time, end time, modified date. Well, in here we only have 4 specified, but the first one is covered because it's an automatic number. You'll notice, just as we did up here, we just specify the name, we specify our start time and our end time. The last one, though, we're going to say default. And what this means is we have, I put a default on this column called getDate, which is exactly this up here, which means that if a value is not supplied, if default comes in, then it's going to use the default, which is getDate. So this works the exact same way as this one. If we highlight this code and hit execute, one row affected once again. If we head back to our shift table here and refresh it, there we go. We now have an early bird column in there. So worked the exact same way. The only difference is we did not specify a column list, but we had all of our columns covered, and we specified that we wanted to use the default value that was specified when we created the modified date column. Now let's do one more thing with the insert statement here. Let's say that we did want to, in fact, insert our own IDs into the shift ID column. As I mentioned, this is an auto number column, otherwise known as an identity column. And again, it's done for us. Every time we insert a record, this number is incremented by 1. So let's say since we did miss a number, however, let's say we did want to put this number back in here for whatever reason. Well, we can do that using the insert statement. And how you do this is you'd use the identity insert option. And this is basically used by calling the set command here, followed by the name of your option. Of course, this one's identity insert, followed by the name of your table, and then on or off. So this will turn identity inserting on. And basically what that means, we can create our own numbers. So auto numbering is turned off as soon as you flip this switch on. So what the common thing to do here is to turn this on, run your statement to insert your data, and then turn it back off again so auto numbering may resume. And that's all we're doing here. We're turning it on. We're saying insert our own number here, shift ID being 100, followed by some sleep deprived data, sleep deprived shift, and then turn it back off when you're done. So if we highlight this code and hit execute, one row affected, we head back to our shift table here and hit execute. Boom, look at that. Now we have our shift with a shift ID of 100, sleep deprived with a crazy start and end time there. And that's all there is to it. So that's the insert statement, very painless to use, and again, that's what we use to put data into tables. Now, taking this a step further, let's say that we wanted to update existing data in our tables. We use what's called the update statement. And update, again, a simple statement to use. It's just simply the update keyword here, followed by the name of your table that you're updating, followed by a set, followed by our list of columns. So in this case, what this would do here is we do not have a where clause here, so we don't have a filter on this. This would update every single record in a table. And what I'm doing here is a calculation. Update statements are good for things such as this, where maybe we have a commission percentage that changed, and we want to change everybody's commission percentage and up it by 2%. Well, what this will do is let's go ahead and take a look at our sales.salesperson table here. If we come on down, there it is. In our sales.salesperson table, if we open this up, will show us inside of here, it's all of our sales information. Here's our commission percentage. Let's say that we had a good year and we wanted to give all our sales associates a better commission rate. So we'll up their percentage by 2%. And that's what we're going to do. So if we go back into our table here, or back into our query window, we highlight our code here, we hit execute, boom, all these rows were affected, and now all of these rows have been recalculated to have a greater commission percentage multiplied by 2%, whatever it was before. Now, taking a look at this, what this did is it actually said set commission percentage equals commission percentage times 0.02. What this means is it took the existing percentage, and that's what this is here, commission percentage itself. This column is going to equal whatever it currently equals multiplied by 0.02. So we're increasing it by 2%. And again, since we don't have a where clause, that's going to do it for every single record in the table. So just be cautious when you do not have a where clause on your update statement, and just be sure that you do fully intend to update every single record in a table, because I've personally seen disasters when programmers forget that where clause and accidentally update every single record in a table. Now, we can use a where clause. Very simple to do. Just like the select statement, you just add a where on the end of it with your filter condition, and then we'll only be updating specific records. And that's what we're doing here with this next statement here. And again, same syntax, update followed by table name. We use the set, only this time we're updating multiple columns inside of our table, not just one column. And you can see you don't have to use the set statement for every column. You just use it once and then separate your columns with a comma. So we're going to go back into our shift table here, and let's say we wanted to update our record number 100 here and update our sleep deprived back to, or just change the name here to the graveyard shift. And also, we want to update our modified date because we're updating the record. And this is what we're doing. So we're saying update that table, set our name equals graveyard, and our modified equals whatever, again, the results from the get date function will return where our shift ID equals 100. If we highlight this and hit execute and flip back to our shift table here and refresh it, now it's changed to graveyard, and our update date was also updated. So again, that's just updating specific records rather than all records in a table. Now, another common thing you'll see happening with the update statement, let's say that we wanted to update data in our main table here, but we want to put a filter on a column in another table. Well, we can do that using joins. And that's right, joins aren't just for select statements. We can also use them for update statements to put filters on data in another table. And we can also use for the delete statement for the same way, which I'll show you coming up here shortly. Basically, how this works is simple. Everything from the from on works just like a select statement. And if you're going to be doing things like this, use an alias, and then instead of saying update table name, you just say update the alias for whatever table you're doing the updates, for whatever column in whatever table you're doing the updates on. And let's say for this example, we want to update all of our products that are bikes, and we want to set the reorder point to whatever it is minus 50. Let's say it's almost summertime, our bikes are selling like hotcakes. We want to lower that reorder point so we can stay ahead of the curve and keep our inventory up, so of course we can meet the demand of our bike sales. So that's all we're going to do here is say update our alias table here, production.product, set the reorder point to whatever it is now minus 50, and then we're going to do that where our PPC here, which is our production.product category table, equals bikes. So all of our bikes. The only way to get to this product category through the product table is through the product subcategory table. So we're actually going a couple of levels deep into our join to get to the category of our bikes. But the point is here that this will take and only update all of the records in our product table that are actual bikes. So pretty cool stuff here. If we highlight this and hit execute, we get 295 rows affected. So all of those bikes have been updated with the appropriate reorder point, and we did all that through a join. So that's the update statement, pretty painless to use. We also have the delete statement. If we want to remove records out of our tables, it's pretty simple to use, and it works similar to the update statement here. If we just did a delete followed by a table name, this would delete every single record out of that specific table. So if we were to run this, we'd delete all of our salespersons. Again, just be careful if you're going to do things like this. Good for development purposes, you know, deleting records in case you're doing development and such. But in a production environment, be very careful. Also, same thing here. If you want to put a where clause to delete specific records, simple. If we want to delete that shift 100 out of our human resources table, we just highlight our code here. We're going to say delete from the human resource.shift table where shift ID equals 100. Boom, that row is now gone. Also, if you want to delete based on a join, same thing works. Again, we don't have to deal with updating columns or inserting record into columns because we're removing the entire row here. So you just simply specify what table you're deleting from. If you're going to do it based on a join, use that alias. In this case, this would delete all of the bikes out of our production.product table. So just to show you though, you can use joins if you need to make decisions to delete rows from one table based on data in another table. We can do that. So that's DML, a big look at the data manipulation language. Again, the four most popular statements in all of SQL, no matter what database platform you're in, is select, insert, update, and delete. And that's how we work with the actual data. Now let's take this a step further, and I'm going to open up another query here. We'll go to File, Open File, and I have a T-SQL script here. And inside of here, we're going to learn just common things that you can do with Transact SQL that'll just help you out in everyday scenarios. The first one is using variables. Using variables, very simple to do. Variables are really going to come into play when we're working with stored procedures and such, and we use them as parameters and also inside of our application and such, or inside of our stored procedure. But they are also good for scripts. You know, you're scripting something out, you want to put all of your static data up top in case you use it multiple times, then you only have to change it in one spot. But using variables, very simply, you just simply use the declare statement followed by your variable name. Your variable name has to be prefixed with the @ sign here, and then followed by the type of data that it's going to go into. Next, if you need to put data into a variable, you can use the set statement, set variable name equal value. And you can see if you're going to use strings, you have to enclose them inside of single quotations. And then we can use this variable inside of our queries. So here we're going to say select first name, last name from our person.contact table, where last name like, and then we're going to pass in this variable name, the first letter of the last name, and then we control here. This is nice because the user or anybody could supply this last name here, and then we supply the wildcards. If we want to return data where the wildcard is after or before or both, we have control of that. The user doesn't pass that in. So if we do something like this and hit execute, boom, we get all the A's. So now we just have to simply manage this this actual data in one spot here, and then we can run it all day long, as you can see there. So that's how you use variables. Very, very simple. Also, you can see here we use the set statement to set the variable. You can also put data into variables based on the results of a query. So like we do down here, we're saying we're declaring a variable salaried employees as an integer. We're going to say select rather than set because we're returning data from an actual query here. Set this variable is going to equal the results of count from human resources.employee where our salaried flag equals 1. So this will just take whatever that count comes out to be, pop it into our variable, and then we're just going to use the print statement to print it out into our result window. So highlight this code, hit execute, there it is, 52, printed out inside of our message window rather than in an actual data set. Now, another thing we can do here is use what are called functions. And functions are great. They really are. They can save you time. They help us do things. Really, all they are is just predefined operations built into SQL that we can call. Some of them take parameters, and then they go out, they do the work, and they return results based on what we pass into them. We've already been using functions up to this point. Back in our DML here, you can see just scrolling in here, I can see we've used the getDate function. We've used also the count function in here. We've used the new ID function to generate a brand new GUID. So we've used functions, and again, they're very simple to use. There's functions that range from date and time functions, tons of them, string functions to manipulate things, math functions, you name it, a wide range of functions in SQL Server for us to use. And they're easy to pick up and learn too. I'll show you when we get in dealing with syntax how you can quickly and easily learn and find out what functions are in SQL, what parameters they take, and what results they return. And I'm going to show you a couple of date functions here. First one we're going to look at is date name, and this is a really cool little function. We just simply pass in our date part. So if it's a month name, do we want the name of the month? Do we want the name of the week, the name of the year, whatever the case may be? We're going to say we want the name of the month that this individual, all of our employees were hired in. So that's all it takes. It takes the interval or the date part as they call that, and then also the date. And that'll return us the month hired based on this date. So if we just highlight this code here and hit execute, look at that. We get, again, all of our employees, their login IDs, and the month that they were hired. Now, let's say we wanted to order that by hire date. Well, I'm going to go ahead and just comment this out here and say order by hire date. If we do this and we hit execute, you can see, look at that. It's not really sorting. It's sorting it by the date underneath the hood, but we want it listed out. We want all of our January employees through all of our December employees listed out. Well, the best way to do that is we could use another function here called month. And month just takes a hire date, or takes a date, excuse me, and then will return the actual numeric value. So it's essentially going to order it 1 through 12 here. Just a slick way of ordering by dates when you want to do something like this and extract the name out. If we do that, check it out. Now we have all our employees from January to December sorted by the actual month name, not the actual date. So slick way of doing things like that, but that's all the month function does. Just simply returns the numeric value of the date that is passed in. We also have some text functions, as I mentioned before. And this time, let's say that we wanted to concatenate the first name along with the first character of the middle name and then the last name all in one. So we have everyone's fully printed name here. Well, I'm going to show you what this would look like without these functions here first. In fact, let's just take out the coalesce function here so I can show you what that is all about. And there we go. So what this would do here is this should give us first name plus a space plus we're going to the substring function just simply takes the column that you're going to extract a string out of, where you're starting at, so what position in the string, and then how many over you're counting. So we're going to say we want just the first character. So we're going to say based on the middle name column, start at the first character and count over 1. So this will just give us the first character of the middle name and then add a dot into it to abbreviate it and then put a space after that and add the last name. So what you'd think this would give you, if we highlight this and hit execute, is something like this. The name followed by the first letter of the middle name, a period, followed by the last name, right? And this looks good, except for there's a lot of null values in here. Why is that? Well, the reason we get null values is because null plus null, a null added onto anything will nullify it. So basically what it's doing here is if there is no middle name, it's a null value, then it's taking this when it concatenates to it and nulling out the first name and also nulling out the last name. So that's where the coalesce function comes in handy, because the coalesce function basically takes the first non-null value. So if it's null, what we're doing here is we're saying if the combination of all of this here, the substring, is null, then just add an empty space into it so it doesn't nullify the first name and the last name. So the coalesce function, very, very useful. It is kind of an advanced function, but I just wanted to just show you some of the text functions here and how we can use them. If we do hit execute, however, check it out. Now, if there is no middle name, it doesn't nullify it. It instead just adds nothing to it, basically an empty string to it rather than a null value. And see, now we get all of our names printed out. And just to show you some of the cool things you can do using some of the math functions here, I'm actually created a little tiny select statement here that gives us a random character, A through Z, a random character every single time. How we do this is using the random function here. The random function always returns a value between 0 and 1, a float value. So basically what that means is a very, very, very specific number. If we just do a select random, look at this. It's always going to return to a random value, a random float value between 0 and 1 with that many decimal places. So what I'm doing is I'm multiplying that by 25. All right, so we always get something between 0 and 25.999999. And then we're going to do a round here, round it to 0 decimal places. So basically what I'm doing is we're getting a random number between 0 and 26. Now the char function gives us, it takes just a letter or a number between 0 and however high the ASCII character codes go up to, and it's always going to return a random ASCII character code, or basically an ASCII character code based on the number you type in. I'm saying 97 plus 0 through 25, or excuse me, 0 through 26, because starting at 97, we get the alphabet, lowercase alphabet. So if we say 97 plus 0 through 25, it's always going to be a random alphabetic character between lowercase a and z. And that's all I'm doing. So if we highlight this entire code block, let me get this select statement out of there. There we go. And hit F5, we're always going to get a random letter between A through Z. Pretty cool stuff, huh? So I just thought I'd show you that. And something like this, then we could highlight this code, we could copy it, head on up to our variable here, pop that into our variable, check it out. We're always going to get random last name results now. Pretty cool. So just thought I'd show you that. Some cool things you can do with functions. We also have some control flow statements. So if we need to make decisions within our code, we need logic branching, things like that, we can use the if statement. And the if statement, very common in all programming languages, very simple to get the hang of here. We're just saying if this condition is true, then run this block of code. Otherwise, run this block of code. And that's where the else comes into play here. And you do have to use the begin and end statements to define a block of code if you're going to use else. You don't if you don't use else. And how this works here, what we're saying is we're using a subquery. We're saying, and a subquery is inside of these parentheses here, we're saying if the results from this query are greater than 0, then run this block of code right here. Else, run this block of code. And all we're doing here is we're just grabbing a count from our employee table where the salary flag equals 0. So we're just saying we have any contractors currently available. If we do, it's going to print out yes. Yep, and we do. So very simple to get the hang of the if statement. We're going to be using these when we talk about stored procedures. And you'll also see them used in scripts quite often, especially for just like this example here where we don't have an else statement. We're just basically checking if an object exists. If it does, we're going to drop it because maybe we have a script down below that's going to recreate it or create a newer version or whatever the case may be. So we're just saying if this object, the results from our object ID function is going to basically check this object here if it exists. If it does, it's going to return the actual name of the object. If it isn't, it'll return null. So if it's not null, in other words, if it does come back with the fact that this object exists, then we're going to drop it. So you'll see that very, very common thing. Also, you can do conditional processing using the case statement. In other words, you want to do conditional formatting, things like that. Well, the case statement, very simple to get the hang of here. You just do a case followed by the name of the column that we want to do a case on. And we're just saying when this column equals W, then actually print out women. If it equals M, then print out men. When it equals U, print out universal. So basically the style column is either going to have a W, an M, a U, or a null in it. So that's where the else comes into play. If it's anything but any of these three, then print out NA. It's not available as the style name. And you'll see this used very often. Case is great for doing things just like this. You want to put conditional formatting. You want to just change the way the data looks, whatever the case may be. You can use cases for that. Also, we have another case statement down here. We're saying when the make flag equals 1, and this is used on a bit field. Make flag is equal, it's either 0 or 1. We're going to say if the make flag equals 1, then we're going to print out made. Otherwise, we're going to print out manufactured. A little easier to read than 0 or 1, right? True or false. And then you can put an as on the end of here to, of course, put an alias. Just an alias on this column, alias on the results of our case statement here on both of these. So if we highlight all of this code and hit execute, there we go. We have all the names of our product and then the style of the product and then if it was made or manufactured. And you can see some of these, all the NAs have null values for the style. Maybe it doesn't apply, of course, because parts such as lock nuts don't have a style, right? Only clothing does. So if we scroll down here, check it out. Here's some clothing, long sleeve. We have some universal long sleeve jackets there. We have some women made, looks like some yellow style of coats. And then if it's made or manufactured. So the case statement, great on things such as that, conditional formatting, and it's simple to use. So again, these are just common everyday things that we'll be doing in Transact SQL. And again, I just wanted to get your eyes familiar with how these things look and how they work. The best way to learn these things is through practice. Just get in, get your hands dirty, write some of this code, get familiar with how the syntax looks, how it works. It's actually pretty painless. And again, I just wanted to get your eyes familiar with them because this is the kind of stuff that we're going to be working with throughout pretty much the rest of the series because we're going to be dealing with a lot of code, working with stored procedures, views, tables, functions, you name it. So just getting you familiar with this kind of things. One other thing I want to get you familiar with is the data definition language, getting you familiar with how to create actual objects. And the data definition language, there isn't really a standard on how it looks because if you're creating a database, it's going to look different. If you're creating a table, if you're creating a procedure, it's all going to look different as far as the implementation goes. But the create statement itself is going to be the same. So this is what I want to get you familiar with, however, is how to use all of these things and also, more importantly, how to understand syntax. So for instance here, using DDL to use the create, say we wanted to create a database. Well, the minimum thing to create a database here is simple. Create database and the name of your database. It'll pick up all the default file names and everything. If we hit execute, it's going to go ahead and create our database name testdb. Simple as that. If we pop open our Object Explorer here, pin it down, I'm going to scroll back up here into our SQL Nuggets sql2005 prod server here. I'm just going to right click on our database here and choose refresh. There it is, testdb. As simple as that, right? Now let's say we wanted to add a table in there. Well, You can see I use this use command. This is just manipulating this box up here without actually changing it. It just changes the context of your connection to that database. So we're going to say use test to be, create a table here called test table with the test ID column as an integer, test text column as an varchar. We hit execute. Now we go into our database here. There it is, test table. Simple as that. But the point here is that no matter what you're creating, if it's a database, a table, or procedure, the syntax is going to be different for each one. So if we wanted to create a stored procedure here called sp get test data, and it's going to just select everything from test table, there we go. Now if we come down to programmability, go into our stored procedures here, there it is, sp get test data. So creating is going to all be used, no matter what object you're creating, it's going to be using the create statement here. Simple as that. Modifying objects, we're going to be using the alter statement. So again, the common DDL statement is alter. So how it's actually implemented is going to be different whether you're altering a table or altering a procedure here. For instance, say we wanted to add a column to our test table, because we only have a couple of them here. We'll add a flag in here called test flag. We do alter table followed by the table name, and then we say add the name of our column followed by the data type. We hit execute here. Boom. We're in. Now if we refresh our columns, there it is, test flag. Same with our procedure. If we wanted to alter our procedure here, we just say alter procedure, name of the procedure that we're altering, and then in this case, we're going to add a parameter called test ID, and we're going to say select everything from test table where the test ID equals whatever the user supplies for that test ID. So we highlight all this, we hit execute. Now if we come down into our programmability here, we expand our parameters. Now we have a parameter underneath the stored procedure. Our final DDL statement is our drop statement, and very simple to use. You just do a drop followed by the type of object followed by the name of your object, and boom, you can see I just wrapped these around with if statements just to show you that it's a common thing. So we drop our table here, we just highlight it, hit execute, boom, our table's gone. If we want to drop our stored procedure here, this actually has to say procedure, drop procedure sp get test data. We highlight it, hit execute. And if we want to drop a database here, you have to use the master here. We're going to switch to our master. You can't drop a database if you're in it. So we'll switch our connection to our master here and then drop it. Boom, gone. So now if we switch back into here, we refresh our databases, everything we just did has been wiped out. So DDL, very, very powerful. Again, I just wanted to get you familiar with the fact that we use create and the type of object that you're going to create objects, alter, the type of object that you're going to alter to modify objects, and drop to delete. Now, one other final thing I want to show you here is syntax. Syntax is huge. It's just like learning any other language out there. If you want to learn a different language, the first thing you're going to do is you're going to learn the syntax, because if you know how everything is structured, how everything is used, then learning the actual language is a piece of cake, right? And I'm going to show you some slick ways to do this now. For instance, let's say that we wanted to learn how to create a database. Well, if we highlight create database and hold shift in your computer and then hit F1, it's going to take us right into the help here, and it's going to show us how to create a database. It's going to show us the syntax for creating a database. See that right here? Here's the syntax, all the different options, and really the trick here is learning what all of these means. For instance, the brackets here mean anything in here is optional. Like we just did create database, database name. This is the only required code to create a database, right? And then there's other things in here, and it's really just a matter of learning what all of these all of the brackets, the commas, the the ends here, what all this means, the italicized options here. And really, if you hit this transact SQL syntax convention, which is on pretty much every single page in books online, it'll take you through and tell you what each one of these means. And there's not a lot to it, really. It's very simple to get the hang of. But that's what it's all about, is learning syntax. And you can do this Shift F1 trick on anything. Let's say I wanted to learn what the month command did. Well, Shift F1, boom, takes us right into month, shows us our parameter here, otherwise known as an argument. It takes a date, it returns an integer, and it returns, of course, whatever that month number is for the date that you pass in. And it also gives you good examples in here in books online. This really is the best way not only to learn the syntax of specific things. Take the select statement, for instance. We double click on it, Shift F1, boom, here's everything there is to know about the select statement and what all these things mean, examples, so on and so forth. So if you want to learn the syntax, get down and dirty with it here. Just come on in, double click on anything, hit Shift F1. You'll learn again what that specific function or statement does. Pretty slick stuff, huh? And pretty easy to use. Another thing I want to mention here is conventions. Now you'll notice here in the code that I use, let me just go ahead and go back to our DML query here. The code that I use, you notice I kind of keep a standard on here. A lot of people like to jumble everything together. If I scroll down here, I'll show you one, like I did here, just everything on one line. It's good to stick to a standard. Find a comfortable standard that you're comfortable with. If you're working in a company, I'm sure companies, most development teams have their own standards to abide by. It just makes it easy on everyone. It'll help you read other people's code. It'll help you read your own code. Other people read your code. So I like to stick with the standard here. I keep all of my major select segments here on the left. Everything else is kind of tab delimited here on the right. I separate my columns on each line just so it's easy to read. And you can see this code is well structured and easy to read. So just some tips and tricks that have helped me along in my development days. It's best to get started doing these things in the beginning and make them habits because, again, it'll just help everyone out in the long run. All right, so in the CBT Nugget, we took a gigundous look at the Transact SQL primer. I started off by getting you familiar with all the different components of the Transact SQL language, what DML is, the data manipulation language, and what it consists of, what DDL is, the data definition language is, and what it consists of, and also just some common everyday things that we'll be working with inside of the Transact SQL language. We then took a look at each part individually. We took a big look at the data manipulation language. I got you familiar with all the different parts of the select statement. We took a look at all the different types of joins. I got you familiar then with what are called action statements, the insert, update, and delete statements. We then took a brief look at how to work with common Transact SQL elements, such as variables. Got you familiar with variables. We took a look at functions, some of the different types of functions that are out there. And we also took a look at some of the major control of flow language statements, such as the if statement, and also conditional formatting using the case statement. And then at the end here, we took a look at the data definition language. I got you familiar there briefly with the create statement, the alter statement, and the drop statements, and also syntaxes and how to get familiar with syntax using the old Shift F1 trick to get context-sensitive help, whether it's a function or it's an actual statement. Great way to get help and learn all of this stuff. And also, I just took a brief little chat there at the end about naming conventions and coding conventions because it's great to get a coding convention down early and run with it because it'll save you time, save everyone around you time, and everyone will be happy. So I hope this has been informative for you, and I thank you for viewing.